So what I was saying is that we are building an enterprise DevOps platform. And DevOps means different things for different people, as this summit illustrates, I guess. For us, and it's probably shaped by the profile of our customers, we are usually talking about environments where there are hundreds and thousands of technical staff working on the project or multiple projects, developers, QA, operations, whatnot. And the way we define DevOps, for us, it's an ability for the development teams to do what they need to do, to kind of have this level of self-service, with the operations team being in charge of the policy and policy making and governance of the whole thing. Just to illustrate, let's say I have a really nice web app, which is modern, which is stateless, maybe it's deployed through Docker, it's self-contained. There still needs to be some kind of assurance for the operations teams that whatever gets deployed to production is deployed, say, into with redundancy into X configurations, that before the deployment actually happens to production, that there is a vulnerability check going and so on and so forth. And especially have compliance requirements, of course, because in this case you cannot have just one person pushing changes to production. And Qubell is kind of catering to both, to operations staff and the development staff. Let me illustrate some of the concepts behind this. So what you can see on the screen here is actually it's a live instance of Qubell platform that is being shared with some of the guys over there. So I just hope that we do not bring the internet connection down. It says, and what you can see here is our instance screen. Each of these cards is an instance of a service that's running in a certain environment. In this case, I have 4 in development, I have 2 in performance. And some services can be pretty simple, like the mentioned web service, which can be completely self-contained and not have any external dependencies. For instance, one that I have here, Pet Clinic, is just a 3-tier Java application. But some of them can be more involved. For example, I have a Broadleaf instance here. And Broadleaf, for those of you who don't know, is an e-commerce suite. And this guy is much more involved. If I click here and get to the instance screen, I actually have a number of components as a part of it that has to be managed. I have the application tier, I have a database, I have a load balancer, and I actually have a search cluster based on Apache Soar. If I go to Soar here, I can actually see that it in turn requires a Zookeeper cluster. And Zookeeper cluster is deployed on whatever it is, 3 hosts. As you can see, this kind of a snowflake complexity makes it hard to effectively manage environments. So what Qubell is doing is, whenever this instance of Broadleaf was launched, the platform figures out all the dependencies, finds the necessary services, communicates to controllers to execute the deployment workflows. But it actually starts from getting the VMs. In this case, I believe this one's running on Amazon, even though it's hard to say for sure. It installs all the packages on the target machines. It deploys the application. It makes so that all of the services that constitute an application come together into this one end-to-end e-commerce suite. And an important thing here is that Qubell itself does not really have primitives for working with packages or processes or ports. For that, we are hooking up to deployment tools such as Chef and Puppet and delegate all the node-level configuration to them. We can happily hook up pretty much anything. For instance, we are supporting Windows through just plain PowerShell scripts. We can support things like Docker containers and pretty much any other new technology that the world sends our way. For us, it's a matter of configuration, of the topology, of what the services are, what the interfaces are, how they're connected together, and how to create a new instance, a new blueprint, and then manage it from this basic definition of what the service is. Some of the instances here may be even more involved. For instance, this Hadoop instance over here, which is shared and running in a performance environment, is even more complicated than the Broadleaf instance, because to get yourself a Hadoop cluster, you actually need a handful of necessary services. Things like Hue for monitoring, things like Empower for running queries and whatnot, things like Uzi for workflows. For us, all of these are just yet another services. For instance, I have Uzi here, and I have linked to this web UI created here. None of these things are hard-coded. Each of these components is something that's defined by a manifest, and in the manifest we can say, we want to use Chef scripts for deployment, we want to use Zabbix for monitoring, we want to tie all these things together so that the end user is going to get this kind of interface. And what that means is that if I want to manage, say, Cassandra or something else, which is not really in our catalog right now, if tomorrow I do need to do that, as a customer, I can do that myself. I can create a component. I can bind to, say, existing community chef scripts somewhere on the community side. I might not even need to change them in most of the cases. I just plug them in as another component and have a service that's running in my environment. It goes all the way to the UI level. So, for instance, these logs and whatnot are just plain pieces of JavaScript that will allow people to include in the definition of application. And the actual configuration piece looks like this. So that essentially is the configuration that Uzi is going to give to any application that needs to use Uzi. And to illustrate this, what I have here in my component catalog are all the things that are available to me as a developer on the enterprise to work with. And I have my Hadoop app, which is word count. And I apologize for that. And if I just go and click launch on this instance here, I'm going to get yet another Hadoop app, which has a jar file, it has a test data set, it has a Uzi workflow, but it's going to use the shared Hadoop instance in the environment to do its bidding. If we go back to the Hadoop, we can see that in the activity log, we have things happening with this instance. But all of these applications then can work in parallel, of course. I can create multiple instances for the same application. If I want to, I can go and customize what's actually going to be provisioned. We have this concept of the advanced launch. And if all I need is to start using Hadoop or Zookeeper or some other technology that I really don't know how to configure, how to deploy, how to manage, I don't need to know really anything about how it's deployed. All I need to know is this interface, and I can use it in my applications. So if for the new application I need to use search cluster, someone has probably already put this search cluster, here you have Solar Cloud, in the catalog. If I want to add something else, I can just use this .NET component here and either find something on our repository of open source components or just build my own. But if I feel a bit more involved and want to customize some of the things, for instance, I could go and click Advanced Launch for the Solar Cloud here and change its parameters. For instance, I obviously have its name. I have this default destruction time so that instances, say if you're running on Amazon, something like that, are not held back forever. So it's going to automatically destroy in one day if I do not extend the lease. But then I can customize things that the manifest creator thought would be interesting to expose configuration parameters. So in this case, for Solar, I have ports, I have number of hosts. If I don't want 4, I might go to something else. Solar version, stuff like that. If I don't want to customize anything, I can just go and click launch and get myself yet another Solar. Now, the important piece here is this guy usually takes several minutes to launch because it's running on Amazon, provision VMs, install stuff, yada, yada. I am not going to bore you with that. But the interesting piece that I wanted to highlight is that this is the developer view. But when I'm launching a new instance or I'm upgrading a new instance, I'm always doing that in a context of the environment. And in this case, as you saw, I could have run it in development or I could run it in performance and whatnot. So these things are defined somewhere. And this environment catalog actually shows us what's available, what kind of environments are available for me to launch in. And for us, this is the piece that IT people, that operations are managing. These are logical things. These are the definitions of the policies of what's allowed, what's not allowed in the environment, how the deployment is going to change when you're deploying in developed environment versus production. So let's take a look how development is defined. For instance, this is my default, and that's where I just launched Solar. We can see to have a set of services here which are available for any application that's running in developed environment to be consumed. I have my EC2 account, which means that any application that needs some kind of compute will get compute from EC2. I could have static servers here, and that's probably what I would have for my production. Or I might have rack space here, or I might have something odd like Mesos here that provides Docker containers to me. It's all the same thing as long as they have the same interface. And you can see I also have some facilities for managing keys here. So I could technically use one and the same EC2 account across development and test, but set up different SSH keys so that developers cannot access QA machines and vice versa, while still have the single Amazon account and whatnot. And I have this Hadoop instance, which you probably saw before, which is just yet another service for us. It doesn't matter if it's EC2, a cloud account, if it's a Hadoop service, if it's a database, if it's a shared data file. It's all the same for the platform. It manages the dependencies, the runtime dependencies, in the uniform way. So that's why when I was running the Hadoop application, it actually found itself an instance of Hadoop and deployed its data in there and waited until the job was done. We also have more usual things like environment properties. For instance, if I define something here as a property, then every application that's deployed into development environment is going to have access to this property. A nice thing about these kind of properties versus just general environment properties that are usually associated with the operating system is that, first of all, they're available across all machines, which is nice. But second of all, we will actually check if the application needs an environment property and it's not there, or say it needs an endpoint, an HTTP endpoint, for instance, and it's down. We will not allow it to launch, or we will notify it when it comes up, depending on what's in the manifest. And things like policies proper allow us to override whatever was written in the manifest with our own stuff. So for instance, I could override invocation of small in-memory, say, in-memory database with something like an HA cluster with a new connection string when I'm deploying my application in production. And that allows us to define things like my application, which consists of these multiple things. It consists of a Hadoop job, it consists of a web tier and a database schema, and probably multiple external endpoints. I want to deploy in the minimal configuration with stubs, with probably empty database into my developed environment. In my QA environment, I want to do the same thing, but I want to create a dedicated sandbox so that no one really can go and mess with the test results. And I also want to use these test cases. I want to use the edge cases. I want to use the test data that was specifically created for the QA purposes in order to deploy my application and run the tests on it, in order to certify it in the QA environment. Moreover, in the production environment, I might want to use static hardware instead, and I want to use redundancy for every node for which a redundant configuration is available, and I want to flag all of them which are not redundant. And this, we believe, is what should be the role of operations in the new world, in the DevOps world. It's not being the gatekeeper to all the actions that has to happen in the environment. It's to put these horizontal policies in place and have a platform that actually enforces these policies while keeping developers happy by giving them self-service. So that, I believe, all the time I have. I think I actually ran over. So if you guys are interested in getting some in-depth materials and discuss some of these points, our booth is 6 or 8 right there. And I'll be happy to talk to you. Thank you very much.